welcome back to a new video. We're going over the same skill as before, data representations, this time medium difficulty level. Make sure to subscribe before we get into it, and let's just get started here. So at an altitude of 8,500 meters, Wilbur begins descending his plane. The graph describes the plane's elevation relative to the ground as a function of elapsed time from the moment when the plane begins descending. How many seconds after the plane began descending did the plane land? So we just need to analyze really what's happening here. So when the plane lands, of course the elevation is going to be 0. So we're looking at the point on this graph where the elevation is 0, and that is over here, and this time we're going to take that x value. If we notice, in order to take this x value, we need to understand the scaling. And we can see that as we go across one grid line, our seconds increases by 100. 100, 200, 300, 400. That's an example of that. So if we're just one past 1600, we're going to be at 1,700 seconds. So that is our answer, 1,700. Also, be very careful if they ask you how many minutes after the plane began. In that case, we would have to take seconds, then divide by 60 in order to convert to minutes. So just be aware of them hiding the unit conversions inside of these questions. On to number 2 here. A surveyor is tracking the elevation of a trail at fixed increments of 500 meters. The plot in the DE plane shows the elevation E in meters above the starting point versus the distance d along the trail from the start in kilometers. What is the average rate of change in elevation with respect to distance along the trail in meters per kilometer between the starting point and the highest point of elevation? So average rate of change is just a slope between these 2 points. Don't worry about trying to find the slope of this graph here. We just only need to find the slope between the starting point and the highest point of elevation. So we're going to highlight both of those coordinate pairs. Then we're going to draw a line between them and find the slope of this line. How we can find the slope of this line is that we know that average rate of change, or slope, is y2 minus y1 over x2 minus x1. So we can go ahead and write out the coordinate pairs for each of these. We have the origin as 0, 0, that is our starting point. And then we have our highest elevation, which is 6.5, 130. Always be paying attention to the scaling on both axes. Now we're just going to subtract. 130 minus 0 is 130, so that's our y2 minus y1. x2 minus x1 is just 6.5. So we're going to take 130 divided by 6.5. That is going to give us our average rate of change, or our answer. That is going to be equal to 20. So our answer here is 20. 20 is our slope, or rate of change, between those 2 points. On to this next question here. Looks quite similar, but let's see if it's asking for similar things. The plot in the YP plane shows the production of magnesium P in tons for the YF year after 1990 for a particular mine. According to the plot, what is the maximum annual production of magnesium for the mine to the nearest tons? So our maximum production, we're just looking, where was our production the max, the highest that it could be, to the nearest 5 tons. Let's notice, this was our maximum point right here. That's a maximum on our p-axis, which is where that production of magnesium, and because it is annual, it's just going to be in one of the years. So the year is 5, but we need to take a look at the y value in order to determine our answer. So the scaling here is by 10. But can we notice that the y value where our point is, it is in the middle of a 10. The middle of 10 is 5. So our answer is going to be 85 tons. That was our maximum annual production. Last question here. So the graph in the XP plane represents the relationship between the number of pairs of jeans X that a manager in a department stocks for the season and their profit in dollars. What is the best interpretation of the x-intercepts marked on the graph? So we may not know about these types of functions, but we do know about x-intercepts is where we have an x value, but our y value is equal to 0. And in this case, when y value is equal to 0, that means our profit is equal to 0. So our x-intercepts basically means pairs of jeans where we achieve no profit. Our profit is 0. So our 2 x-intercepts are 300 and 900. Those are the points. At 300 and 900 pairs, of course, if the profit's 0, that means we're just breaking even. So that means that D is our correct answer. The department breaks even. That means we have the same revenue as expenses, meaning 0 profit. If they stock 300 pairs of jeans, or 900 because of those 2 x-intercepts. D is our answer, and that will be it for today's lesson. Of course, this is a medium difficulty level. Next time we're going to be going over the advanced difficulty level. Make sure to stay tuned for that, and I'll see you guys then. Goodbye.